Hello everyone, welcome back to my YouTube channel. Today we are going to see class 8 science chapter number 5 inside the atom. In this particular chapter already we have studied about the atomic structure from the beginning of research work in the field of the atoms. Initially it was discovered by the Maharshi Kanad, the Indian philosopher, who gave the concept of the atom and named it as a Parmanu. After that, the various scientists came, Dalton, Rutherford, and the Niels Bohr. All the scientists have brought a development in the field of the atomic structure. And they gave the different concepts regarding the atoms and the structure of the atom. And finally, they came to the conclusion this all particular research work in the field of the atomic structure brought the existence of the current atomic structure, what we are studying and what we are going to discuss now. So atomic structure, when we talk about the atomic structure or the atom, is formed from the nucleus and extranuclear part. When we talk about the nucleus is the central part of the atom. The entire mass of that particular atom is present or concentrated in the nucleus. And inside that nucleus, we have two types of subatomic particles. Subatomic particles means which is a part of an atom. That's why they are called as the subatomic particles. And two subatomic particles named as the proton and neutron are present in the nucleus. They have labeled over here. You can see they are proton and neutrons, and these two types of nucleons or the subatomic particles are present in the nucleus. Now when we talk about the protons are positively charged subatomic particle of the nucleus or the atomic nucleus, and this particular protons are denoted by small letter p. Proton is represented by the symbol p, and each proton carries plus one electronic charge, or the one electron charge is nothing but the 1.6 into 10 raised to minus 19 coulomb. Coulomb is nothing but the unit for the charge. When total positive charge on the nucleus is expressed in the unit E, its magnitude is equal to the number of proton. So its magnitude we are considering as the number of proton. Suppose there are the 5 protons, then the charge will be considered as a plus 5. The number of protons in the nucleus of an atom is the atomic number that element and is denoted by Z. Atomic number is nothing but the number of proton present in that particular atom, and it's denoted by letter Z. And 1 Armstrong unit or the 1 unit or the 1 Dalton is equal to 1.66 into 10 raised to minus 27 grams. The mass of one hydrogen atom is approximately 1 unit, and the mass of proton we consider as a 1 unit. Further, neutron. As by the name, neutron is an electrically neutral subatomic particle. Protons are positive and neutrons are neutral, means they don't have positive, they don't have negative. Neither positive nor negative. It's a neutral. There is no charge on the neutron. The number of neutron in the nucleus is denoted by the symbol N. Atomic nuclei of all the elements except hydrogen with atomic mass 1U contains neutron, except hydrogen. Hydrogen with the atomic mass as 1, only that particular atom is not having neutron, rest all are having a certain number of neutron, and the number of that neutron is almost equal to the proton. It's in some cases they are different, but in almost every case the number of proton and the number of neutrons are almost equal. After that, the next part what we have, that is the extranuclear part of an atom. The extranuclear part in the atomic structure includes electrons revolving around the nucleus and the empty spaces between the nucleus and electron. So by this, if I want to draw the structure of the atom, then at the center we have this nucleus in which we have the presence of proton and neutron, and electrons are revolving around it like this. Electrons are revolving around this. Electrons are revolving around nucleus. Further part, when we go ahead about the electron, electron is a negative charged subatomic particle and is denoted by the symbol E. Symbol for it is a small letter E, and it is a negative charged. Electrons are negative charged, protons positive, neutron neutral, and electrons are negative charged. Electron carries 1 unit of negative charge. As proton had a +1, here this one is having a -1. Mass of an electron is 1800 times less than that of a hydrogen atom. Its mass is a much less, 18,000 times less. Therefore, the mass of an electron can be treated as negligible. Negligible means almost zero we can consider. Electron in the extranuclear part revolve in the discrete orbits around the nucleus, the orbits being three-dimensional in nature. A term shell is used instead of the term orbit. Shell is used. The energy of an electron is determined by the shell in which it is present. The number of electron in the extranuclear part is equal to the number of proton in the nucleus. Therefore, electrical charges are balanced and the atom is electrically neutral. Now this, if I want to give the explanation for this particular section, actually why the atoms are electrically neutral. Simple concept, the number of proton and number of electron, they are equal in an atom. So if positive protons we are talking about, suppose 10 protons are there and then the 10 electron, so 10 positive, 10 negative, total will become 0. If I am having +10 and -10, this is proton, this is electron, so total is going to be 0 for it, and that's why the atoms are electrically neutral. For the part, they have given the mass of an electron being negligible. Therefore, the mass of an atom is mainly due to the proton and neutron which is present in the nucleus, and that's why it is said that the mass of an atom is concentrated in the nucleus. The mass of number is denoted by the symbol A. The mass number is denoted by symbol A, which is nothing but the sum of number of protons and number of neutrons. And the symbol of any particular element we are writing like this symbol, and then the subscript as the Z and the superscript as the A, where Z is the atomic number and A is a atomic mass number, both the things are same. So here example, suppose if they have taken over here as a carbon C6 and 12. So this is nothing but the atomic number, means the number of protons or number of electrons, and 12 is the sum of proton plus neutron. Further, when we talk about the distribution of electrons, as per the Bohr's atomic model, electrons are revolving in a discrete orbits or the discrete shells, and when we talk about a particular orbit or a shell, then there is a limitation of the number of electrons it can hold, and that the different shells which are having a name as a K, L, M, N, which is also known as a first shell, second shell, third shell, fourth shell, and so on. And this particular formula, that is a 2n square, where n indicates the number of shell. This gives the number of electron that particular shell can hold. For that, we can refer this particular table. You can see here shell, that is a symbol, that is K, L, M, N. These are the shells we have, K, L, M, and N. N, 1, 2, 3, 4 we can write. And as we can see, the formula for the electron capacity, 2n square. So here we will have 2 into square of 2. So square of 2 is a 4, 4 2s are 8. Here for this, if I want to write down, this will be 2. Here what we will write, 2 into 3 square. Square of 3 is 9. And 9 2s are 18. For the next shell, if I want to write down, then 2 into 4 square. If I want to write down it, then 4 and the square of it. So square of 4 is a 16, and 16 2s are 32. So this 2, 8, 18, 32. So these are the maximum number of electrons. Keep this in mind. This is not like minimum number or only this much numbers will be there. No, it's nothing like that. It is a maximum capacity of a particular shell. How many electrons they can have in this particular shell. Like K can hold maximum 2. No electron or 1 electron, it's possible. But maximum 2, 3 will not be allowed. If there is a third electron, that will go in the next shell, that is L shell. L can hold maximum 8. Means if 2 orbits are there, then 10 electrons are sufficient. If there is a 11th electron, that will go in the next shell, that is M shell. So that also we will see, that is the distribution of electrons. We will go ahead, electronic configuration of elements. So just now we have seen this 2, 8, 18, 32 number of electrons, what the K, L, M, and N cells can hold respectively. So we'll go directly towards the next table, which will give an idea about the electronic configurations and how the electrons are distributed. So let's see it. Now, this electronic configuration section. Okay, fine. Now let's see. First 3 already they have done. Hydrogen, number of electron is 1, so it will go directly in the first shell, that is K. Helium, it's having 2 electrons, so it's going in a first shell, that is 2. After that, lithium also 3 are there, so maximum capacity for the first shell is 2. You can see here the capacity they have written. So 2 will come here. How many are left now? 1 is left, so that will go in the next shell, that is L shell. Now let's talk about the further. Next, when we are saying carbon, How many electrons are there? 6 are there. Out of 6, first can hold only 2. Still, how many are left? From 6, 2 are already gone in a first shell. How many are left? 4 are left. So maximum capacity for L is a 8. It can hold 4 electrons because only 4 are left. Okay. Now the next one, nitrogen. In that 7 are there. So 2 will come here. Now how many are left? 5 are left. So 5 will come here. Next is a oxygen. Oxygen is having 8. So here 2 will come. After that, how many are left? 8 minus 2, 6 are left. So here 6 will come. It can hold 8, no problem in that. Okay. Now directly we will go towards sodium. Remaining you can write. Sodium is having 11. So 2 will come here. Next is 8 because only 8 can be held in the second shell, that is L shell. Only 8 can be held in this. After that 8 plus 2, 10. But we have 11. So still how many left? 11 minus 10. Only 1 left. So third shell will have 1 electron. Okay, so electronic configuration, what will be for it? 2, 8, 1. Same way for the others electronic configuration. If I want to write down, for the carbon it will be 2, 4. For nitrogen it will be 2, 5. For oxygen it will be 2, 6. Like that you can write for the others also. Argon, bromine and all. Let's see the last one, that is the bromine, what they have given. Bromine they have given as a 35. You can see the number of electron is a 35. So K can hold 2. First shell can hold 2. Second shell can hold 8. So 8 plus 2, 10. And 35 are there. So 35 minus 10, 25 left. So 25 minus 10. Okay. 25. Here 18 can be there. So 18. 25 minus 18, 7. So last will have 7. Okay, so this is the electronic configuration for the bromine. And while writing, we will write 2, 8, 18, 7. Okay, this is about distribution of electrons. So in this particular session, we will study only till here. Next session, we will talk about the valency and electronic configuration.